Okay, we're finishing up. This is finishing up 10.3. And again, I'm telling you, test-wise, we're talking about Tuesday, right? 10.1, 10.2, 10.3, how to use these different tools we've talked about. The good news is, today's problems uses all of them. Like you have to use all the tools we've learned so far to do today's problems. So it's like a review, all in one spot. So here's what they say. We have a sample of aluminum chloride that has a mass of 35.6. And we want to know how many aluminum ions and how many chloride ions there are in this amount of aluminum chloride. We cool? So let's first write the formula for aluminum chloride. Aluminum and chlorine, is that balanced? Aluminum is a what charge? 3 plus. And chlorine is what charge? 1 minus. Good. Whew. A lot of different answers. So is this balanced? No, I got to put a 3 there, right? Okay. Are you ready? Here comes our biggest, this is our biggest skeleton to date. We cool? 35.6 grams of AlCl3. That's what we're starting with. Can I go from grams to ions? Is there like one conversion to make that change? There's not. So if I can't make it in one conversion, I have to first go to moles. Right? Because the only thing that has grams in it also has moles, right? What tool is that? What tool has grams and moles together? Molar mass, right? Yeah, what we've been doing, what we just did yesterday. Your question? The moles, you always go to moles. I'll show you a picture after we do this. Go to moles. That's like the key piece for stoichiometry. Get moles first, and then you can go anywhere else. It's called stoichiometry. Yeah, there's actually a name for it. Are we cool? How do I find the molar mass of aluminum chloride? The pieces, right? Yeah. So what's aluminum? Help me out. Aluminum has, what's its molar mass?
26.982.
Okay, and there's only one of them. And chlorine, what's it?
Oh, wait, I got you with that one.
35.453? And I multiply it by 3, because there's 3 in them, right? So what's that total? Can somebody add that up for me?
I have it. 133.341.
133.341? Not that I don't trust Richard, but just making sure. 35.453 times 3 plus 26.982. So 133 point, what was it? 341. We good there? Okay. So, in my units, you comfortable we're using molar mass here? I have grams here, because that's what I had there, grams of AlCl3. And here I want moles of AlCl3. The 133 number, does that go on top or on the bottom? I heard a top, but I heard a bottom. It always goes with the grams. Right? The number you find goes with grams. So therefore, Tony, where? The bottom, of course. So 133.341. And how many moles is that in? Cool. Okay.
So 138.341 grams equals 1 mole.
Right.
So then the 35.6 is less than a mole.
Yeah, that's about 1/4 of a mole. Yeah, exactly. We're cool so far?
No, wait, I can copy.
That's fine. I'll put it up on Schoology for you. What comes next? I want to get to ions, right? So how can I go from moles to ions? Like what tool? Avogadro's number. I'm sorry? I do. I would hope you would know between those units, yeah. So here's moles, right? And I'm going, in this case, we're not getting to ions because AlCl3 is not an ion. AlCl3 would be a formula unit. Right? That's the smallest piece of a ionic compound. So where would Avogadro's number go? Would it go on the bottom or would it go on the top? Oh, I heard both. Avogadro's number is how many formula units or how many particles or how many ions or how many paper clips, right? All of that's always in 1 mole. I'll give you a hint. Right now, if ever you see moles, it's 1. Does that make sense? For any of our conversions, the moles are always 1, and the other thing is the number we found. 6.02 times 10 to the 23. Are we cool so far? If I did that number out, well, would someone do that for me? Let's get an actual number we can work with here, just so you can see it. 35.6 times Avogadro's divided by 133.341. Let's just find that number.
35.6 divided by it?
Multiply this, divide by that. There's no worries. Yep, thank you. Sure, yeah, give me a 3 decimal round, or 3 significant figure round. Okay, so 1.61 times 10 to the 21 formula units, and again, this is AlCl3. Are we cool? And again, this is nothing different than what we've done in the past, right? Where we've gone from grams, in this case, to particles. Are we good? Here's the one new piece. Does this question ask you how many formula units of aluminum chloride you have? It asks you what? For aluminum, right? So let me show you these little models here, right? Let's pretend this is aluminum chloride. So aluminum is the green one, the chlorines are the white ones, right? We're going to ignore the little black ball in the center, okay? Aluminum, chlorine, right? This is one aluminum chloride. Are we cool? How many aluminums does it take to make up this model? Just one, right? Just one aluminum. How many chlorines does it take? 3. So are you comfortable that if I had 4 of these models, we cool? How many aluminums do I have? 4. How many chlorines do I have? 12. 4 times 3. Are we cool? Okay? So what this is saying here is that I've got this many formula units of the whole thing, but I just want aluminum, right? So therefore, I'm going to make another conversion that says 1 formula unit of AlCl3 equals how many ions of aluminum? What's the ratio between those? How many aluminums are in one thing of aluminum chloride? 1. Do you remember when we did this before? We did ratios, right? We broke up the pieces. So simply, this number of formula units is also 1.61 times 10 to the 23 ions of aluminum. Does that make sense? We go back to the models. I see some faces that are a little questioning. How many total models do I have here? I've got 4. Each model has 1 aluminum, right? So how many total aluminums do I have? I've got 4, the same number as the models.
I thought you have 4 aluminum, and you have 4 models. Don't you times 3 times 4?
No, what we're saying is the ratio is a 1-to-1. For every 1 aluminum chloride, there's 1 aluminum. Yes, so let's make that change now. If I have 1 formula of aluminum chloride, how many ions of chlorine do I have? I've got 3. So therefore, I will simply multiply that number times 3. And that will tell me the the chlorine ions. So if you take that, my textbook says 4.83. That sounds right to me. 4.83 times 10 to the 23 ions of chlorine. This green number here was doing all these together. You wouldn't have to do that. You could simply take this times this times this times 1 and divide it by here. You could do all the math in one spot and be done with it. I just wanted you to see that green number first before we did it. Are you with me, my friends? I'm recording it right now and it'll be up there. Yes, sir. And again, this is why I teach you using this skeleton, because we could go on, we could make 10 more of these conversions. It wouldn't matter. All you're doing is multiplying the tops, multiply the bottoms, divide top and bottom. It just helps organize so you know what's what. Okay? I want to get back to Andrew's point that he made earlier. This is in your textbook on page 340. It's showing you that in the middle here is moles. And no matter how you get there, if I want to get from mass of a compound to the particles of a compound, I have to first go to moles. If I want to get to the individual atoms or ions, I have to first go to moles, and then it's just showing you moles is the center. You have to always go to moles. That's the key piece. Okay? What I'm looking for you to do is to work on page 339, 42 to 46. And again, we've got a solid 20 minutes almost here. So knock it out.